Okay, so in this video, I want to shift into talking about inequalities again. Specifically, we're going to be talking about quadratic inequalities. And in the next video, we're going to be addressing more generally polynomial inequalities. So here we have, in this first example, we have x plus 7 times x plus 6 is strictly less than 0. And we need to figure out what this answer would look like on the number line. So the very first thing we need to do is we need to figure out the zeros of this inequality. Okay, so remember, if we want to try to find the zeros of an inequality, we more or less treat it like it's an equation, set it equal to 0, and figure out when it's equal to 0. So first we can notice if x is equal to -7, then x plus 7 times x minus 6 is equal to 0. Okay. So what we're going to do is we're going to go ahead and put a dot here at x equals -7. Okay, that's going to be one of our points of interest, so to speak. And we also have if x is equal to +6, then x plus 7 times x minus 6 is equal to 0. So we're going to put another point of interest at x equals 6. Okay, and these will have to be perfect to scale here. We're just trying to get the general idea of what's happening here. So now what we're going to do is we're going to try and figure out what would happen for each interval here. We have more or less 3 intervals we've divided up into. We have the interval from -infinity to -7. We're going to union that with the interval from -7 to 6. And we're going to union that with the interval from 6 to infinity. And this is basically our entire number line except for those 2 points. Okay? So we have to consider what happens on each of these different intervals. So if we have a number that is strictly less than 7, right? So for this interval here, negative infinity to -7, if we plug in a number less than 7, then what's going to happen is x plus 7 is going to be, so let's write this down here. Let's write x plus 7, okay? And we'll write one for x minus 6, okay? And then we'll have their product as well. Okay, if we have this from -infinity to -7, let's say we pull -8, for example. If we pull -8, -8 plus 7, that's going to give us a negative number. So it's going to be negative on this interval here. Okay, so that would be fine. Then we have x minus 6. If we have a negative number, a number less than -7, also x minus 6 is going to be a negative number as well. Okay, so we have a negative number times a negative number. That's going to give us a positive number. Okay, it's going to give us a positive number. So the product is going to be positive on this interval. And you'll notice that we're looking for segments of the number line where x plus 7 times x minus 6 is strictly less than 0. So we're looking for instances where the product is going to be negative. So this is positive. Therefore, we know that the interval from -infinity to -7 is not going to be part of our solution. Okay, let's try the interval from -7 to 6. If you have an interval that includes 0, I always like using 0 as kind of your test value from there. So on this interval, if we have 0 plus 7, that's going to give us positive all along here for x plus 7. Okay, everything from -7 to 6 is going to be positive. And then if we have 0 minus 6, we're going to have negative for this entire interval. Okay, so for this entire interval, we're going to have a positive times a negative. So their product is going to be negative. So that would mean that the interval from -7 to 6 is going to be part of our solution. Okay, so now let's check from 6 to infinity. Okay, so if we plug in a number greater than 6 for x plus 7, we're going to continue to get positive numbers, obviously. And if we plug in a number greater than 6 for x minus 6, we're also going to get positive numbers. So that means that along this interval, we're going to have positive numbers as well. So really the only intervals that we are worried, the only interval that we're worried about, or the only interval that's going to satisfy this inequality is going to be -7 to 6. So what we can do is we can go ahead and do an open circle at -7 and an open circle at 6, because this is strictly less than 0. And we can shade in everything in between. And that is going to be our answer for x plus 7 times x minus 6 is strictly less than 0. Okay, let's take a look at this one. Here we have x minus 5 times x plus 3 is less than or equal to 0. So remember, first we check the zeros. So if x equals 5, then x minus 5 times x plus 3 is equal to 0. So we're going to put a point of interest here at x equals 5. Okay, and then we have a point of interest at also x equals negative 3. So if x equals negative 3, we have x minus 5 times x plus 3 is also equal to 0. So we can go ahead and put in negative 3 as our other point of interest here. Okay, so that's going to divide our number line up into the intervals from negative infinity to negative 3, union with the interval from negative 3 to 5, and union that with the interval from 5 to infinity. And so these are the intervals that we're going to be concerned with. So let's go ahead and put down our factors here. We have x minus 5, we have x plus 3, and we're also going to have their product. Okay, so if we test the values along negative infinity to negative 3, if we pull in any number less than negative 3, obviously x minus 5, or any number less than 0 here, any number less than negative 3 here is going to give us a negative number. So this is going to be negative all along here. And if we pull any number less than negative 3, this is also going to be negative. So we're going to have a negative number times a negative number, and that's going to give us a positive number for this interval. Okay, so and because we're looking for numbers that are less than or equal to 0, to 0, then we have to exclude this interval as part of our solution. Okay, now let's try from the interval negative 3 to 5. If we pull in any number between negative 3 and 5, this is going to be a negative number along here. Okay, but x plus 3, if we pull in anything greater than negative 3, this is going to become positive all along here. Okay, so for this whole interval, we're going to have a negative number times a positive number. That's going to give us a negative number. And we're looking for intervals that would make this less than or equal to 0. So this is going to be a part of our solution. Now, if we test from 5 to infinity, anything greater than 5 is going to make x minus 5 positive, and then obviously x plus 3 will also be positive. So this would become a positive number. So we're really worried about the interval from negative 3 to 5, except we want to include the points where it is equal to 0 as well. So instead of an open circle, we're going to have a closed circle right here, because we want the points where it's equal to 0 as well. And then we're going to shade everything in the middle. Okay, let's do another one. Here we have x minus 4 times x plus 2 is greater than or equal to 0. Okay, so check our points of interest again. So if x is equal to 4, then x minus 4 times x plus 2 is equal to 0. So we're going to put a point of interest at x equals 4. And then if x is equal to negative 2, then the same thing. X minus 4 times x plus 2 is equal to 0. Let's give this one some more space here. Okay, so our points of interest, our intervals of interest are going to be, let me change this to a dash here. Oh no. Okay, so we have negative 2 and 4. So our intervals of interest are going to be from negative infinity to negative 2. We're going to union that with the interval from negative 2 to 4. And we're going to union that with the interval from 4 to infinity. Okay, so let's have x minus 4. We'll have x plus 2. and we'll have their product as well. Okay, so if we look at the interval from negative infinity to negative 2, anything in that interval minus 4 is going to give us a negative number here, okay? And if we also include anything from negative infinity to negative 2, this is also going to be a negative number. So we're going to have a negative number times a negative number, which is going to give us a positive number. Therefore, negative infinity to negative 2 is going to be positive, and we want them to be this to be greater than or equal to 0. So this would be part of our solution. Okay. How about from negative 2 to negative 4? Well, if we plug in 0, we'll have 0 minus 4, that's negative. So this would be negative, and this would become positive along this interval as well. So therefore, we have a negative number times a positive number, which is a negative number. And we don't want that. We want this to be greater than or equal to 0. So that would not, negative 2 to 4 would not be part of our solution. Okay, and then from 4 to infinity, we're going to have everything is going to be positive here. And also anything greater than 4, we're also going to have positive here. So we're going to have a positive number times a positive number, which is going to give us, as you might expect, a positive number. So because we're looking for the intervals that make this greater than or equal to 0, we're going to have the interval from negative infinity to negative 2, and we're going to include the point negative 2. So we're going to put a little circle, a closed circle here, and we're going to shade everything to the left there. We're not going to shade anything in the middle, but we are going to include the point 4, and we're going to have everything to the right. Okay. So now let's take a look at this next problem here. Here we have x squared minus 2x is less than or equal to 8. The first thing we need to do is we need to see if we can factor this quadratic, okay? If we can factor this, then this will make our lives a lot easier. So we're going to start by taking 8 away and setting this inequality equal to 0. So that's going to give us x squared minus 2x minus 8 is less than or equal to 0. Okay, so we need to find two numbers that multiply together to give us negative 8 and add together to give us a negative 2. I'm thinking negative 4 and 2 should do that. So we'll have x minus 4, x plus 2. Did we just do that one? No, we did not. Oh, we did. We did. We actually just did this one. So the same principle would apply here, except this is not the same thing. It's slightly different. We're looking for less than or equal to 0, but this is the same factors. So we know our points of interest already are going to be 4 and negative 2. So now we're going to be more or less just working the opposite side of this one. Thankful this was not exactly the same problem we had before, just a little extra step. It's a little bit different, so that's fine. So we'll have x minus 4 times x plus 2 is less than or equal to 0. Okay, so let's write out the factors. We'll have x minus 4, we'll have x plus 2, we'll have their product. But we can use a little bit of our information from before. We can go ahead and use whether it's positive or negative on this whole section. So we know for everything from negative infinity to negative 2, we're going to have negative numbers. So it's going to be positive all along here. Okay, so everything is going to remain the same as before. So from here, we're going to have negative, and we're going to have positive. So this will become negative. Okay. All right, and then we're going to have everything is going to be positive here. Okay, so this will become positive all along here. So we're looking for the intervals where it's negative, and we're going to include the point where it's 0 as well. So we're going to have just the interval from negative 2 to 4. We're going to close that off, and we're going to shade everything in the middle.